Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is my top power TP-128 IPM in-runner, aka a Lightning Rods XXL. My understanding is that he machines this off. But otherwise, that and some minor shaft work or whatever, that's about the only real difference between his version of this motor and the one that you get from the factory, I think. Temp sensor, things like that. Anyway, yeah, I wanted to swap out the shafts, and the factory shafts that came in them were like this with this 12 millimeter end on them, and I had purchased these beefier shafts that have 20 millimeter ends on them, and I'll turn that down to exactly 3/4 of an inch after a while. But yeah, I wanted to be able to swap them out, and so I had to make a tool to be able to pull those out, and that's what this is. And I'll get to that in a minute. So one of the things that someone suggested was that these shafts were going to be really hard, and they are kind of hard, but they're not too hard for carbide. So I chucked this up in my my lathe, and then used a carbide insert, and I was able to take this shoulder right off, because you know that used to be like this, which means that the bearing is trapped behind it, and this is trapped behind it. So now that that shoulder is off right there, which just took like a couple minutes at most to do, and this, by the way, is about 5 thousandths smaller in diameter than the actual bearing land is. So that piece can slide right on without too much trouble. It's just a little bit loose in there. And then I've got the bearing land right behind it. So all I'll have to do is, like, you know, tap this into place, and that'll work out just fine. And once it's in place, once the armature is trapped between the front bearing and the back bearing, it's not going to go anywhere. So I'm not worried about not having the shoulder in there at all. In fact, yeah, once I had it all apart, I was thinking, yeah, I really don't need to put a circlip ring in here and here to trap that bearing. It's probably never going to be a problem. But yeah, I probably won't bother with it. Anyway, so here is the inside of the TP-128 cover. The casting on here is pretty decent. There's no milling marks in here at all. So this might have been like sandblasted or something like that after it was milled. You know, because it's definitely got a texture to it. Anyway, yeah, old shaft, machined just fine on my wood lathe, or my metal lathe rather, with a carbide insert. New shaft. I'm sure this is probably not going to machine any harder or any more difficultly, but yeah, I'll take that shoulder off and then reduce that diameter down to 3/4 of an inch on the nose. Alright, so here is obviously the armature with the shaft extracted from it, and it survived pretty well. I did make a tool, you know, early experimentation back when I first got these motors. That was basically the same shape as that, just made out of aluminum. Yeah, the two of them are obviously very attracted to each other. But what I found, and it was basically just like this without the bolt hole pattern in it. What I found out was when I put a 3-jaw puller around the edge of the thing, is that the piece of aluminum, even though it was 10 millimeters thick like this is, it would kind of bowl. You know, the center part wouldn't move and the outside edges would. And so what I've noticed is that this center piece right here would pull down, and this outer part here would kind of start pushing up. And I considered that to be probably bad form. You know, sort of thing you don't really want to see happen. So I stopped using that part before I ever even got the shaft off, and just waited until I came up with a better idea, which was, of course, this. So this piece of steel was a 1/2 inch thick, and I've machined it down some because I just needed it to fit underneath here. So I didn't quite have a 1/2 inch of a gap in there, and especially not like when it's sitting up here on the edge like this. Had a little bit less than that, so that's about 10 millimeters thick. Anyway, now it slides up underneath here, no problem. You know, other than the fact that it's heavily attracted to the magnets. And then these two rings right here, so this one, actually the way I do this is this piece goes in, I kind of get it centered up, this little piece slides into place here, and then 2 screws go in from either side at an angle here and here, like that. There we go. And this piece has got an angled threaded hole in either side of it and a hole straight through there. So once this is all assembled, then this piece is supported in 3 places, so that's going to provide good support on the bottom of the armature. And then this piece goes on, and through that hole right there, that goes into that threaded hole, so this goes on here. And then this piece here is slightly larger, as you can see, and that gives me a lip right here that I can get the 3-jaw pullers on to be able to pull that off. And then, of course, the puller, its screw, sits on the end of the shaft right there and basically pulls all this up and pushes the shaft out. So worked perfectly. I only made one change after it was all built, and you can see this little shoulder on here, and that's true for all this part right here. So this shoulder right here will catch on these little kind of like studs or rivets or whatever you want to call them when you're sliding this piece into place. So I just rounded that outside edge so that it would slide over top of those, because otherwise that outside edge was like this. I just slightly beveled it and it would catch on those things and not want to go over them. So yeah, with this rounded edge on here, now that passes over there no problem. Anyway, that's about the only change I made. If I were ever to make one of these again, I probably wouldn't do it out of hot rolled steel like I did, because, well, as you can see, this steel and magnets, they kind of love each other a good bit. Yeah, and so that makes assembly a little bit harder, just because, you know, like, you got to line up all the through holes for everything and get it all threaded together, and the magnets are fighting you with all that stuff. But that's not a huge deal. It's just that, you know, if this was all brass, I wouldn't have to hassle with any of that stuff. But it also wouldn't be as stout as this either. Once this is assembled on the armature, and then I've pulled the shaft out, then I still have to get this off. And so through the thing being assembled, get that screwed out there. You know, there's this center hole right here, like that, and I can stick a socket in that hole right there and press on that lip, and then use another 3-jaw puller to then push all of the steel off of the armature, because I can't do it by hand. It's just simply too powerful, the magnets are. But yeah, with the 3-jaw puller, I can pull this straight off of the armature and release it off of there. And in fact, that's how I did it for this. So yeah, with brass, I wouldn't have to worry about all that stuff. It would just simply slide right off, no problem, because it wouldn't be attracted to the magnets. So I doubt I will ever make another one of these things. You know, getting this thing apart this way works just fine. If I was dealing with a lot of these motors, I would definitely not use this steel one because, well, it's nice and stout, but it's also more hassle factor because it is so attracted to the magnets. Anyway, I hope that this helps some folks out. And if somebody does buy some of these TP-128 motors, you know, I put the link to the Top Power Alibaba page on my 2 TP-128 videos, so you can see where to buy them from. And if somebody's in the USA and they want to send me their motor so that I can pull their shaft out and replace it with this one or whatever, or they want me to machine some diameter on here that's not whatever that is, yeah, you could send that to me and I could use my handy dandy puller assembly that I made to pull your armature off and to rework your shaft or whatever. Yeah, anyway, hope to help some folks out. Took a bit of work to make this thing. I started this several days ago and put in some time on it over this past week, working out exactly how I was going to do this and then building it, and here it is. And it worked perfectly. No damage to the armature at all. You can probably see that right there. This was already damaged when I opened up the armature, and there's another spot like that too. Yeah, this armature was not really well cared for from the factory. Anyway, I didn't do those. They came that way to me. But yeah, this did not cause any damage to the armature, so that's good. Alright folks, take care. Talk to you later.